Hi, folks. Let's look at this problem from chapter 4, section 4. We are given a woman's age, and we are given in the US the birth rate in 2019 for every 1,000 population. I assume they mean for every 1,000 women rather than for every 1,000 people. And so notice these ages are equally spread out by 5 years. But there's a jump between the ages of 17 and 22. The birth rate increases from about 19 to about 71. So that's over 50 births per 1,000 women. But then from 22 to 27, it goes up about 27 births per 1,000 women. So the rate of change is probably not constant. These X values are equally spaced, but these Y values are not equally spaced. And in fact, the Y values go up and then they start to go down. So probably a line is not going to be a good fit for this data. So I'm going to take a moment and enter that data into my calculator. So I'm going to go to Stat, Edit. I have some old data in here. I'm going to go up to L2, press Clear, press Enter, go to the left, go up to L1, press Clear, press Enter. My age values, my X values are 17, 22, 27, 32, 37, and 42. And I'm going to make sure I entered those correctly. Then my birth rate for the first one is 18.8, 71.0, 98.0, 100.3, 52.3, and the last one, 11.6. So I'm going to verify I entered those correctly. Okay. So now I will paste that in here. So there's my data. And then I'm going to, from here, I'm going to second quit. That takes me back to my home screen. And I probably don't want to use the standard viewing window from -10 to 10. So I can either go into the window settings and choose what I think is reasonable, or I can go into my zoom menu and choose choice 9. Zoom stat, or even let's do zoom fit, that's better. Choice 0. And I should have, I'm going to go ahead and press enter here. But I had some stuff in my Y equals menu that I didn't get rid of yet. So let me get rid of that. And now let's go to zoom 0, zoom fit. So there are several different choices after the first 8 or so that you can see. Let's do zoom fit. Okay, let's do zoom stat. Zoom 9. There we go. I maybe then want to look at my window and say, you know, I can hardly read those grid lines. So let's maybe change the scale. In the X direction, we might want to count by 5s. In the Y direction, if we're going up to more than 100, I don't know, let's count by 20. And then maybe I will make my X values a little nicer. Maybe I'll start at 0 and go to 50. And in the Y direction, how about from -20 to positive 120? And then I'm going to hit the graph button, and that's much easier to read. I think I'm going to change it one more time. I would kind of like to see the Y-axis better. So I'm going to go back into my window. And for my X values, I'm going to start at -5 instead of at 0. Let's look at that window. Then we'll draw the graph. And I like that picture better because I can see both the X-axis and the Y-axis. So on the X-axis, we have age in years. This is 50. This is -5. in the Y direction, we have births per 1,000 women. And at the bottom, -20, which wouldn't make sense in this problem. And at the top, positive 120. So this would be 20, 40, 60, 80, 100. And that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, great. So that really doesn't look like a straight line. Nevertheless, I could run a linear regression on it. So if I do stat calculate a linear regression, choice 4, and my X values are in list 1, my Y values are in list 2, and I want to store that equation in, say, Y sub 1. So variables, Y variables, function, Y sub 1, press enter again. And here are my results. Notice that my correlation coefficient, R squared, is about 0.016. In other words, R squared is about 1.6%. That means even if I used this, the best line possible to model this data, knowing the age of a group of women will not help me predict the number of births per 1,000 women at a given age if I use this linear model. And since I stored my equation in Y1, I can go to there to make sure it's there. Okay, and there's lots of digits. And I can press graph. And we can see that that line has a negative slope of about -0.5. It has a y-intercept of not quite 74. So here's 60, there's 80. But that line does not look anything like that data. And the data seems to be U-shaped and it seems to be upside down, but it's U-shaped, it's not in a straight line. So let's try a quadratic regression. So again, we're going to go to stat, over to calculate, but this time we're going to choose choice 5. Our X values are in list 1, our Y values are in list 2. This time, I'm going to choose to store my equation in Y sub 2. So my Y sub 1 from my linear regression will still be there. So I'm going to go to variables, which is next to clear, over to Y variables. Choice 1 is function, but this time I want to store it into Y2. I'm going to press enter to move down to the calculate flashing icon and then press enter again. And here's what I get for my quadratic regression. And when I do my quadratic regression, I see that my R squared value this time is 0.971. Actually 0.972, if I round off correctly. So as a percentage, that would be about 97.2%. That's very close to 1, whereas when we did our linear regression, it was very close to 0. R squared is close to 0 or 0%. And then when we did the quadratic regression, R squared is close to 1 or close to 100%. Again, if I want to verify, I can go into my y equals menu, and I can see that it typed in a quadratic. I can press graph. There's that line that doesn't fit the data very well at all. And here comes the parabola. And that parabola looks really good. It looks like it exactly goes through 2 of our data points. Probably doesn't exactly go through those points. And it comes very close to all of the other points on that data points. So we can see that that quadratic regression is a much better fit than the linear fit. And we could tell that when we looked at our scatter plot to begin with, that first it goes up and then it comes down. So it's like an upside down U or an upside down parabola. And so we would probably expect that a parabola is going to fit the data better than a line will. And then let's see what other questions we need to answer. Use your model to predict the birth rate for 35-year-old women. So use the better model to predict the birth rate for 35-year-old women. We can do this a couple of different ways. We could trace along the parabola, or we could ask our calculator to calculate a variable for us. So if we go to second calculate, which is, I already forgot now which button that was. And then choose choice 1 and type in 35 and press enter. Notice that my little cursor, my flashing X cursor now, it's on the straight line. And that predicts a birth rate of about 55.8 per 1,000 women. But that's using the linear regression. We don't want to use the linear regression. We want to use the quadratic regression, the parabola. We can jump back and forth from our different graphs by using our up arrow and our down arrow. So right now the graph is on Y1, which is the linear graph, the one that's graphed in blue. If I want Y2, I can just press the down arrow and my cursor jumps to the parabola and the colors match the color I had set for Y sub 2. And I can see that this equation has an x squared in it. And so since the parabola is a much better fit than the straight line, I'm going to use this predicted Y value rather than that predicted Y value. So the predicted birth rate for 35-year-old women is about 79.1 births per 1,000. And I'm going to use the same words in the problem, population, although I think they really mean women, but because I don't know for sure, I'm going to use their same words. And I would go look up the data source to find out if they really mean per 1,000 women or per 1,000 people. But my guess is they mean women. If they had said per 1,000 population of women, then it would have been clear. Or if they had said per 1,000 people, that would have been clear. Or if they had said per 1,000 women, that would have been clear. I think that's it for this problem. Remember that when you're all done, you want to go into your Y equals menu and clear out your equations, but also you want to turn plot 1 off. And then go back down so that you can verify that it's not highlighted anymore. And you also want to clear your data. The easiest way is to do stat edit and then go to the top of each column and press clear and press enter. Notice that if I'm in a particular cell and I press clear and then enter, oops, maybe it won't let me do that. It used to just clear out that one number. So if I put, say, 5 there now instead of 27. Then press enter. Now I've replaced the whatever it was before with a 5. But if I want to get rid of all of the numbers, I have to go to the top of the column, press clear and press enter. Now all of the data is gone and I can second quit and I'm back home. I personally like to always do a zoom standard also when I'm all done, just back so I can see the origin and from -10 to +10. Take care.